All right. I want to talk about Cygwin and Zenity and file replacement and some questions that are coming up from a lot of people, and I'm answering them one at a time. So let me talk about it in here for everybody. But any questions before we start, other than how to make Zenity work in Cygwin or how to replace your reservation in the file? All right, so there's a few things. There's finding a name in the reservation file. There's removing the name from the reservation file. There's adding a record to the reservation file. And we already talked about the \r business yesterday, right? Using sed to get rid of that. So, but we can talk about that more if there's questions. But let's deal with the file. That's boring. All right, so there's a sample reservation file, and if you want to add something to that, right, the trick is just use greater than. So if you type a command and you say greater than file name, it writes the output in that file. If you say greater than and a file name, it'll append it. So you might do something like this. So name equals someone, from equals here, to equals there, and so on. So you might say echo $name, and this file is pipe delimited, so we'll use pipes, $from pipe, $to, greater res.txt. And so res.txt has a new line at the bottom with that information, and obviously you want to put in the dates and the number of bags and all that stuff. But greater will append. Okay, so that's how you can add something to the bottom of a file. So searching for a record. So one way to do this is with grep. Grep is our search command. So grep $name res.txt. Bless you. So if name is equal to Nick, I can say search for $name in res.txt, and it'll print out any record that matches that name. If my name is something that's not in there, and then I grep for that name, it won't print anything out. Okay, so if you just want to know if the name is already in the file, here's what you can do. After you do a grep, well, take your grep command, throw the output to the bit bucket because we don't care about the actual output. But run your grep command, and then immediately after that, look at the value of this status variable, $? If it's equal to 1, it means that grep did not find the thing you were looking for in that file. So name is equal to haha, it did not find haha in that file. Now if name is equal to Nick, and I do the same grep, and then I look at $? That's equal to 0. 0 means it did find it in the file. So the whole trick is do your grep, throw the output into the bit bucket. And then you can check $equal. If it's equal to 0, it means that it found that name in the file. If it's equal to 1, it didn't find it. So that's one option, is for looking for a name in the file. If you want to say something like, you know, we see you already have a reservation with us, would you like to change it or keep it? Or something like that. Okay, if you simply want to get rid of a name that's already in the file, one way to do that is with grep-v. So if I search for my name in reservation, it will show me the line containing my name. If I say grep-v, that reverses the behavior of grep. It shows me every line that does not contain my name, which are just the other records in there. So now I could do this, and I could put the output into res2.txt. And now res2.txt is the original reservation.txt with that record removed. So that's the other option. grep-v $name res.txt greater than res2.txt, and then maybe do something like move res2.txt back into res.txt. And now you've basically removed that line from res.txt. There's other ways you can do these things, but that's some examples of ways that'll work.
Just do a straight one right there. Just pipe it straight into res.txt. Does that work?
That can be dangerous. It'll actually stop you from doing that. The reason it can be dangerous is you know, technically this is deleting the output file and then starting to add to it. And if my input file was very long, it might not suck that all into memory. It might read the first chunk of it, and then when it tries to read more, it's already gone. All right, so any questions about any of that? Like I say, I keep getting these questions piecemeal, so that should sort of settle it. Mm-hmm.
What if, like, the name of the traveler is the same as like a destination?
Yes. So you get to demo this, so you can be very careful not to let anybody named Paris travel on your airline, or just make Paris not a destination. Or you can do something different. So for example, the name has to be in the beginning of the file. So let's say someone is traveling from Nick to somewhere else, and your name is traveling from somewhere to Nick, right? Right, so it thinks that Nick's in there 3 times, right? So what can we do? We could search for beginning of the line, followed by my name, followed by a comma or a pipe in this case, since it's pipe delimited, and that'll restrict it to just that one line. All right, other questions? All right, let's play with awk. So awk, just like said, normally we say awk and then we list a program and then we have a file that we want to process. And it applies this program as it ingests each line from the file. Or we can say dash F and have a program file. So our programs can be more complex. And awk is very much based on the idea of fields within each input line. Right, so there's our file of foods. Right, so $2 means the second field on each input line, so the type of food. And so my program is saying print the second field from each line, and it just prints out the type of the food. And by default, spaces separate one field from another. If you want to use a different kind of separator, you can say dash uppercase F and some character which will be the separator. So if you have a comma separated file, you can do dash F comma and it'll break your fields up accordingly. Okay, so what does a program look like? It's basically a pattern, and then inside curly brackets, an action. And so an example of an action is print. And we can say print $1, print $2, and so on. I can print $1, $2, $3, $4, and I get my original file, but without any spaces in there. I can print these out with commas, and it'll throw a space in between each one. Right? And multiple spaces on here aren't significant when you're trying to read a field. The first field on this first line is apple, the second one is fruit, the third is red, and so on. So if I do this, right, those spaces basically go away. They're just delimiting one field from another. So $1 is apple, $2 is fruit, and when I print them out with a comma, then I just get a single space in between. But if I wanted to print them out in a different order, right, that's easy to do.
Would it be accurate to think of the fields as columns, or is that?
That's exactly how to think of them, yeah. So first column, second column, and so on. And we also have a $0. And $0 is just the entire input string. It's the collection of all fields treated as a single variable. So we have $1, $2, and so on. We have $0. We also have special variables in here. For example, we have something called NR, which is the record number. So if I print NR, comma, $4, $1, $2, $3, I get a record number in the front of each line. Right? So NR increments by 1 each time it ingests. Or if I just want to take my original file and just throw a record number and a colon in the beginning of each line, right? I can do NR and then a colon in quotes and then $0. And these patterns can be a variety of things, including begin and end. So here's a program. The first thing it says is begin. So when we match that pattern, which will happen before we read the first line of input, I'm going to print out 2 number signs and then a header, name, type, color, cost. Then we're going to print out some underscores, which is also part of the header. And then this curly bracket on the second line that ends the action for that pattern. And then I have another line in my program, and there's no pattern here, so this will happen on every line of input, which says print out the record number, followed by a space, followed by line 0. So if I do awk-f f1 foods, right, I get my file of foods with a header that doesn't happen to line up, and numbers on each record. Right, so I can make a pattern which says at the end, and end happens after it's processed the last record from the file. I wanted to print total number of records and then print out the value of NR. And so when I run that, I get this final line of output that says total number of records 17. All right, here's another program. So the pattern here we're looking for is the length of the first field is less than or equal to 5. And so this says read a record. If the length of the first field of that record is less than or equal to 5, print out that entire record. Otherwise, do nothing. So this should print everything where the type of the food is 5 characters or shorter. Alright, so it prints out apple and Oreos and kiwi, but it skipped spaghetti and it skipped coffee and it skipped shortbread and so on. So we can use length. All right, here's another pattern we can look for. NR equals 3, comma, NR equals 6. So this says read a line from the input, and if the number of the record is between 3 and 6, then we want to do whatever comes next, which in this case is print out the record number and print the original line. Right, so we got records 3, 4, 5, and 6. All right, more complex program. There's no pattern here, so this will happen on every line of input. If $for tilde / cheap. So this is a general thing we can do. Okay, the tilde means see if this regular expression is found inside this thing on the left. This is something you find in Perl if you ever programmed in Perl. It shows on regular expressions like this. So we can put in, you know, something more than just a particular pattern. We can put in a string, or we could put in a whole regex. So here we're just going to check to see if field 4 contains the string cheap. And if it does, we're going to change field 4 to say under $2. Otherwise, we're going to set field 4 to be over $2. And then we're going to print out $0, which means the entire field. All right, so we change that fourth field accordingly. Alright, well, we can have variables in awk, and kind of like bash, you don't need to declare these things. I can just start using this variable called cheap, and it will treat it as the right kind of variable, so I can do the things I'm trying to do, like increment it. So I've got two variables, cheap and expensive. I initialize them to 0. That matches the begin pattern, so that happens before it starts reading anything from the file. It's an initialization. And then each line that it reads, it's going to do the following two things. If the fourth field contains the pattern cheap, it will increment the value of cheap. If it contains the value spendy, it'll increment the value of expensive. So it's going to count up how many of each type I have, and then the end pattern will happen at the end of all the input, and it'll do two prints, and it'll print out the number of cheap foods and the number of expensive foods. Right, and we're using a printf style output, so %d, all the usual stuff works there. All right, so 11 cheap, 6 expensive. And again, this is a whole lot easier than C, right? C, to find the fourth field, we need to start moving through our string and look for a space and count up until we've got 3 spaces, and then, you know, take everything up through the next space or the end of the line and compare it with a string compare and bump up these counters and put that in a big loop, use fgets, and then do some prints at the end. Yeah?
So why is it like printf instead of echo?
It's just how awk prints things. It might take echo, I'm not sure, but if with printf I can do things like %d to translate. I mean, I could also do this, I believe. Right, and that works just as well. But if you want to do more fancy formatting, it's nice to have the power of printf. But I don't think echo, yeah, I don't think it understands echo. Awk is kind of its own language. It looks in some ways like Bash, it looks in some ways like C, but it's really its own thing. And it's really GNU Awk that we're running. And there's a few things you can read about it. All right, the next thing is really fun. The next thing has to do with what we call an associative array. And we may have talked about these with respect to Bash. We'll definitely talk about these in 222 when we talk about data structures called hashes. And associative arrays are magic. They were a hammer that I discovered early on in my programming career. And once I found this hammer, I just carried it with me and I used it for everything. Right? I've got to make a spreadsheet. Let me use my associative array hammer on that, you know. It's the universal tool. It's like super powerful. And it's fun to work with. Okay, so here's what an associative array is. If we have a plain old array of integers, let's call this thing, you know, data. What do? We say data bracket 0, data bracket 1, data bracket 2. This is the first, second, and third element in the array, right? And this array of integers in C, for example, we access the elements of that array by using an integer. And these integers start at 0 and they increase, and they're sequential. And if there's 100 things in this array, then we can access it with data bracket 0 all the way through data bracket 99. Okay, so that's a plain old array. Imagine an array that you can index more generally. Not just with 0 and 1 and 2, but maybe with -2. Or maybe with 143,219. Or maybe with 2.65. Or maybe with a string like haha, or somebody's name, or whatever else you want. So an associative array is a very general type of array that we can index with pretty much anything, most commonly with strings. And you can do a lot with this kind of thing. For example, suppose you want to store people's phone numbers. So you want to store their office extensions, right? I can make an array called phone. And I can store the value of element Nick to be 2115. That's my extension. And I can store the extension of IT by storing it in an element indexed IT. I don't know if this is IT's phone number. I don't think it is. 2222. And so I can make this array, and if I want to know Izad's phone number, what do I have to do? I just say print phone bracket quote Izad. And it'll print out the 4-digit number for his extension, assuming I've saved it. It's associative in the sense that with this piece of data, this key, there's another piece of data, this value associated with it. And this is arguably part of the mechanism that makes our brains work. Because you smell something and somehow that's associated with some memory in your brain of, you know, someday you were at school, and associated with that day at school is a conversation you had with some friend, and associated with the recollection of that friend is some album that you used to listen to together, right? And there's this big long chaining of things, right? This is associated with that, is associated with this, and there's cognitive theories that suggest this is how conceptualization occurs, or this is part of the mechanism for it at least, right? For forming concepts as opposed to just retrieving data, right? Which computers are good at, but actually conceptualizing things. And it's like I say, it's a really powerful hammer. You can use it for lots of things. So if you're writing a compiler, right, you need to keep track of variables, and you need to figure out where you're going to store each variable in memory, right? And so I would make an associative array called variable locations, and variable locations bracket variable name equals where it's stored in memory. And anytime I want to, increment that location, I just hit my array with that name, gives me the memory address, and I just say increment that memory location. All right. So you can go crazy with associative arrays in the best possible way. And awk understands associative arrays. So we can make an array and we can index it with whatever we want, and we can store values in there. And we could store, integers or strings or, arbitrary data structures, floats, characters, whatever. So in awk, if you have some array and you say bracket something, right? All of your arrays are automatically associative. And whatever you put in here, that's now a valid index to be used for accessing elements of that array. Okay, so let me show you what you can do with this. Here's a 3-line awk program. Well, 4 lines if you count the curly bracket. The single action to take on each line says foods bracket $2 plus plus. All right, so let me just pull this in here so we can look at this. So what's awk going to do? It's going to read the first line of the file, and $2 is equal to fruit. So this is going to say foods bracket fruit plus plus. Okay, this automatically makes foods an associative array because we're putting brackets after it. And it says that there's an element we can access called fruit. So the foods array looks like this in awk's brain. There's an element called fruit. Now everything's initialized to 0, so when I say foods bracket fruit plus plus, the starting value was 0. This is going to be equal to 1 now. So after reading the first line of input, foods bracket fruit will be 1, and that's all that's in the foods array. Okay, now it reads the second line, and $2 is again fruit, and so the one line of our program says foods bracket fruit plus plus. So it executes this again. Well, foods bracket fruit is currently 1, so when I do plus plus, now it's equal to 2. Now it reads the third line, and field 2 is cookie. So now that instruction says foods bracket cookie plus plus. Well, there is no element indexed by cookie yet, so it creates one and initializes it to 0, and then it says plus plus, so that's a 1. And then the fourth line, it reads the fruit again. It says foods bracket fruit plus plus, so this becomes a 3. And then the fifth line, it reads $2 is drink, so that says foods bracket drink plus plus. So it creates this, initializes it to 0, does the plus plus, and it's 1. So as this one-line program, foods bracket $2 plus plus, is executing, what it's doing is it's creating elements in this foods array, indexed by different types of food, and it's keeping track of how many times it sees them. And then there's one more line of code here, which fires at the very end, and this is a for loop. and this is a typical for loop for associative arrays. It says for, parentheses, food type in foods. Okay, so that needs some explanation. So for food type in foods. So what this does is it says, okay, foods is presumably an associative array. I don't know what the valid indexes are. It's not like a regular array. I can just look at elements 0, 1, 2, 3, 4. I got to know what the indexes are, right? If I don't know that there's a fruit and a cookie and a drink, how can I deal with those? So we make a for loop for food type in foods. So what does this do? First, it's going to set food type equal to one of these possible indexes. Maybe it'll be fruit, maybe it'll be cookie, maybe it'll be drink, don't know. Let's say it's equal to cookie. Okay, and then it'll execute the body of the for loop. When it comes back up here, it will set food type to a different index. So it won't set it to cookie again, but it might set it to fruit. Execute the body of the for loop, come back up, set it to a different index that we haven't already used, so it won't be fruit or cookie, so it would be drink. Execute the body of the for loop, come back up. After food type has been assigned each of the possible values, the loop exits. So it's kind of like for I equals 0, I less than 10, but it's really for food type is one of these indexes. Food type, has no other index we can assign it to. So it's something we call an iterator. So for each of those possible values of food type, it's going to print out number of %s colon %d. The %s gets replaced with food type, so it'll tell us the type of food, and then the %d gets replaced by the value of foods bracket that index. So let's run this. All right, and so there's a tally of our different types of food. And if I wanted to do this by color, it's the only change I have to make. I'll build up my associative array based on the values of field 3. And there's my tally based on color. Does that seem useful? All right, there's another special value we can use, NF, which is the number of fields. Inside the current input line. All right, so here's a slightly longer program, but still pretty short. So I've augmented my first line of the program. Instead of just bumping up counts bracket $2, I have a for loop which says for item equals 1, item less than or equal to the number of fields, item plus plus, and I increment counts bracket $item. So what does this do? It sets item to 1 and it says counts bracket $1 plus plus. And then it sets item equal to 2 and it says counts bracket $2 plus plus. So the previous example used just the second field, right, the type of food. This one is using every field from the first input line and it's keeping track of how many times that occurs. And so if I just send some text through this, this will basically go through each word on the first line and tally up the corresponding count in this counts array, indexed by each word. and then it'll go on to the second line, the third, and so on. And then when we're done, we have our same closing for loop for word in counts, print the number of times that word occurs, followed by the word. So I've got some sample text here. This was just a news story I pulled off from Reuters. So if I do awk, program name is end, and I feed it this text, it gives me a word count of how many times different things occurred. And if I do a sort numerical, right, then I get a list from lowest to highest frequency, right? And there's the guts of PA4, right? Words instead of phrases. And you know, that's all it takes. Right? The reason that's so easy is because of the associative arrays, right? That's the sense in which they're this really powerful hammer. It's one of the things you can do with them. So I'll show you one other trick. Here's a file called index, and normally we say number sign exclamation mark /bin /bash, which means if you just type the name of this file, it will run it with /bin /bash. Well, I've changed the shebang to say let's run this with user bin awk with an F flag, and now if I say index, this script will automatically run through awk, and if I put a file name after it, that will be the argument to awk. So now index is a 755, so I can just say index text, and there's my output. And if I say index War and Peace, there's my War and Peace output, and we can sort that, and there you go. So TR is a program, transliterate, and the only time I've ever used it was like this, TR, little a through Z, big A through Z, which basically says replace little a with big A, little b with big B, and so on and so forth. That's a 2 uppercase. Right, so that changes everything into uppercase. Right, and if I want to remove parentheses, I can just run it through sed and say replace those, or I could put them in brackets and be fancy, right? And then I can run that into index. So we can do some of that pre-processing, and we could do some other things to break it into phrases. Right, so we could look for those things that begin or end a phrase. We could change all of those into a standard character, and then we could say with awk, let's make our field delimiter that character, and then use exactly the same awk script, but now the first field would be the entire first phrase, the next field would be the next phrase, and so on. Then it would be tallying phrases for you. So even though bash is you know, seems kind of goofy sometimes, and it's, you know, you hear people talk about kiddie scripting, right? So doing a denial of service with bash, it's a pretty low cost of entry to learn bash. Bash is still really powerful, right? If you think of particular ways of putting things together, you can do a lot with it. And awk and sed are really useful commands to have in bash, and throw those together in the right way, and lots of stuff is possible. Right, And we can do stuff like this. Here's a program that will just print 10 numbers. Right, it's just a plain old for loop. Here's something that'll print out the sum of the first 10 integers. And I don't even need to give it a file here, right? It's not actually reading anything from input. It's just saying sum equals 0, do a for loop, add to our running sum, and then print it out after the for loop. And here's a program that prints prime numbers from 3 to 1,000. And it's just kind of a standard nested loop prime number tester. And if our number is not composite, it will go ahead and print it out. And I can run that with awk, and there's a list of prime numbers. So I don't even need to use this to process files. I can just use it as a kind of quick go-to programming environment, a little more natural than doing things in bash, right? I can say if, and I can do arithmetic and so on, but I still don't have to compile it and declare variables and stuff like that. So there's lots of capabilities there. All right. So we'll start talking about some system programming concepts tomorrow. And we'll round out the week talking about processes and creating processes and controlling processes. And that'll take us through into next week. All right, so I'll see you tomorrow.